Volcanoes come in many shapes and each one forms in a different way. When people imagine a volcano, they often picture a steep mountain with a crater at the top and lava flowing down its sides, but that is only one of many possible forms. In reality, volcanoes can be small cones, enormous gently sloping mountains, rounded domes, or even vast collapsed basins. The shape of a volcano depends mainly on the type of magma beneath the surface and how it erupts. Some magma is thick and sticky, trapping gas and causing explosive eruptions, while other magma is fluid and flows easily across the ground. Over thousands or even millions of years, repeated eruptions build up the different volcanic shapes we see today. By studying these shapes, scientists can better understand how volcanoes form and how they might behave in the future. Let's look at the most incredible shapes of volcanoes. Cinder cone volcanoes. One of the simplest and most common volcano shapes is the cinder cone. These volcanoes are usually small compared to other types, but they are easy to recognize because of their steep slopes and the crater at the top. Cinder cones form during explosive eruptions when gas-rich magma is blasted out of a volcanic vent. As the magma shoots into the air, it breaks apart into small fragments of molten rock. These fragments cool quickly as they travel through the air and then fall back to the ground around the vent. Over time, the fragments pile up and gradually build a cone-shaped hill. The pieces that form these volcanoes are called cinders or scoria, which are lightweight volcanic rocks filled with gas bubbles. Because these materials are loose and porous, they accumulate at fairly steep angles, often around 30 to 40 degrees, giving cinder cones their sharp triangular appearance. At the summit of most cinder cones, there is a bowl-shaped crater marking the location of the eruption vent. During an eruption, glowing fragments of lava may be thrown hundreds of meters into the air before landing around the crater and adding new layers to the cone. Cinder cones are generally not very large, with many reaching only a few hundred meters in height. But what makes them remarkable is how quickly they can form. In some cases, a new cone can appear and grow to its full size within just a few years. A famous example is Periquitán in Mexico, which suddenly emerged in a farmer's cornfield in 1943. At first, cracks opened in the ground and ash began rising from the soil. Within days, volcanic fragments were erupting into the air and a cone started forming. Over the next several years, the volcano continued erupting and eventually grew to more than 400 meters tall, burying nearby villages under ash and lava. Once the eruption stopped, the cone remained as a permanent feature in the landscape. Cinder cones are extremely common in volcanic regions and often appear in clusters known as volcanic fields, where dozens or even hundreds of small cones may dot the landscape. Each cone represents a separate eruption that occurred at a different vent. Although their eruptions are usually short-lived compared to larger volcanoes, the cones they leave behind can remain on the landscape for tens of thousands of years. Shield volcanoes. At the opposite end of the volcanic spectrum are shield volcanoes. These volcanoes are among the largest volcanic structures on Earth, yet their shape is very different from the steep cones formed by explosive eruptions. Instead of rising sharply above the landscape, shield volcanoes spread outward across enormous areas with very gentle slopes. Their name comes from their resemblance to a large shield lying on the ground. Shield volcanoes form from lava that flows very easily across the surface. This type of lava is usually basaltic magma, which contains relatively low amounts of silica and therefore moves more freely than thicker types of magma. During an eruption, lava pours out of vents or long cracks in the ground and spreads across the landscape like rivers of molten rock. Each eruption creates a new layer of solidified lava that extends far from the central vent. Over thousands or millions of years, countless lava flows accumulate and gradually build a massive volcanic structure. Because the lava spreads so widely before cooling, the slopes of shield volcanoes are extremely gentle, often rising only a few degrees above the surrounding land. Despite these shallow slopes, shield volcanoes can become enormous. The largest volcano on Earth, Mauna Loa in Hawaii, is a shield volcano. When measured from its base on the ocean floor to its summit, Mauna Loa rises more than 10 kilometers, making it taller than Mount Everest when measured from base to peak. The Hawaiian Islands themselves are essentially the tops of huge shield volcanoes that formed as the Pacific tectonic plate slowly moved over a hotspot deep beneath the Earth's crust. As magma rises from this hotspot, it produces repeated eruptions that gradually build the islands higher and wider. Eruptions from shield volcanoes are usually less explosive than those from many other volcano types because the magma allows gases to escape more easily. Instead of violent explosions, the eruptions often produce lava fountains and long flowing streams of molten rock. Even so, these eruptions can still be dangerous because lava flows can travel great distances and destroy anything in their path. Shield volcanoes may also have multiple vents and fissures instead of a single central crater. Lava sometimes erupts along long cracks in the ground known as fissures, creating wide lava fields that cover large areas. Over time, some shield volcanoes also develop large summit depressions called calderas, when parts of the volcano collapse after magma chambers beneath them partially empty. Despite their relatively calm eruptions, the immense size and long history of shield volcanoes make them some of the most impressive geological formations on Earth. Lava domes. Not all volcanoes grow through flowing lava or piles of volcanic fragments. Some volcanoes form from magma that is so thick it barely moves once it reaches the surface. These structures are known as lava domes. A lava dome forms when extremely viscous magma slowly pushes its way out of a volcanic vent, but cannot flow far from the eruption point. Instead of spreading outward across the landscape, the magma piles up around the vent, gradually forming a rounded mound or dome-shaped structure. The magma involved in lava dome formation usually contains high amounts of silica, which makes it thick and sticky. Because this magma moves so slowly, gases trapped inside it often struggle to escape. This can cause pressure to build up inside the dome, sometimes leading to explosive eruptions that break apart parts of the growing structure. When sections of a lava dome collapse, they can produce dangerous pyroclastic flows, which are fast-moving avalanches of hot gas, ash, and volcanic rock that rush down the slopes of the volcano at extremely high speeds. These flows can reach temperatures of several hundred degrees Celsius and travel quickly through valleys and across surrounding landscapes. Lava domes are often smaller than other volcano types, but they can still pose serious hazards because of the explosive potential of the magma involved. They frequently form inside the craters of larger volcanoes after major eruptions. A well-known example occurred at Mount St. Helens in the United States after the massive eruption in 1980 removed much of the mountain's summit. In the years that followed, thick magma slowly rose inside the crater and formed a growing lava dome. Over time, the dome expanded, collapsed, and rebuilt itself as new magma continued to push upward. Lava domes often appear rough and irregular compared to other volcanic shapes. Their surfaces are typically made of fractured blocks of hardened lava that shift and crumble as fresh magma slowly forces its way upward. Although they may not reach the enormous size of shield volcanoes or the towering heights of stratovolcanoes, lava domes represent another important way that volcanic landscapes form and evolve over time. Stratovolcanoes. One of the most iconic volcano shapes on Earth is the stratovolcano, also known as a composite volcano. These are the tall, steep mountains that most people picture when they think of a volcano. Stratovolcanoes often have a symmetrical cone shape, rising dramatically above the surrounding landscape with a central crater at the summit. Many of the world's most famous volcanoes belong to this category, including Mount Fuji in Japan, Mount Vesuvius in Italy, and Mount St. Helens in the United States. The name stratovolcano comes from the layered structure that builds the mountain over time. The word strato refers to layers, and these volcanoes are formed through many alternating eruptions that deposit different materials on top of one another. During some eruptions, lava flows down the slopes and solidifies into thick rock layers. During other eruptions, explosions blast ash, pumice, and volcanic rock fragments into the air, which then fall back and settle around the volcano. Over thousands of years, these layers gradually accumulate and form a large volcanic mountain. The magma inside stratovolcanoes is usually thicker and more viscous than the basaltic magma found in shield volcanoes. Because the magma is thicker, gases inside it cannot escape easily. Pressure builds inside the magma chamber until it is released in explosive eruptions. These eruptions can produce towering ash clouds that rise high into the atmosphere, sometimes reaching tens of kilometers in height. Stratovolcano eruptions can also generate pyroclastic flows, which are extremely fast-moving clouds of hot gas, ash, and rock fragments that surge down the sides of the volcano. These flows are among the most dangerous volcanic hazards because they move quickly and carry tremendous heat. Many destructive volcanic disasters in history have been caused by stratovolcano eruptions. A well-known example occurred in 79 CE when Mount Vesuvius erupted and buried the Roman cities of Pompeii and Herculaneum beneath thick layers of ash and volcanic debris. Despite their dangers, stratovolcanoes are fascinating geological structures because they record long histories of volcanic activity. Some stratovolcanoes remain active for hundreds of thousands of years, periodically erupting and adding new layers to the mountain. Their steep slopes and dramatic eruptions make them some of the most visually striking volcanoes on Earth. Caldera volcanoes. Sometimes volcanic eruptions are so powerful that they completely reshape the volcano itself. In certain cases, after a massive eruption empties a large portion of the magma chamber beneath the volcano, the ground above it collapses inward. This collapse creates a huge depression known as a caldera. Unlike the steep cone shape of many volcanoes, calderas are large, basin-like structures that can stretch several kilometers across. In some cases, they can be even larger, forming enormous volcanic depressions that dominate the surrounding landscape. Calderas form during some of the most powerful eruptions on Earth. When a huge volume of magma erupts from beneath the surface, the underground magma chamber becomes partially empty. Without the support of the magma below, the ground above collapses inward, creating a massive crater-like depression. After the collapse, volcanic activity may continue inside the caldera. New vents, lava domes, or smaller cones may form within the collapsed basin as magma continues to rise from below. Over time, calderas can develop very complex landscapes filled with volcanic features. Some calderas eventually fill with water, forming deep lakes. A famous example is Crater Lake in Oregon in the United States. Thousands of years ago, a large stratovolcano called Mount Mazama erupted in a massive explosion that emptied its magma chamber. The mountain then collapsed, forming a wide caldera that later filled with water to create the deep blue lake seen today. Another well-known caldera system lies beneath Yellowstone National Park in the United States. The Yellowstone caldera formed after several enormous eruptions in the distant past. These eruptions were so powerful that ash spread across much of North America. Calderas are important because they show how dramatically volcanic landscapes can change during large eruptions. Instead of building a mountain higher, these eruptions actually cause the volcano to collapse and reshape the landscape entirely. Fissure volcanoes. Not all volcanic eruptions come from a single central crater. In some cases, magma rises through long cracks in the Earth's crust known as fissures. When lava erupts along these cracks, it can produce a type of volcanic activity known as a fissure eruption. Fissure volcanoes do not usually form tall mountains like stratovolcanoes or cinder cones. Instead, they create long lava flows that spread across wide areas of land. During a fissure eruption, molten lava pours out along the length of the crack, sometimes producing spectacular curtains of fire as fountains of lava shoot upward along the fissure. The lava then spreads outward, forming large sheets of hardened rock. Over time, repeated fissure eruptions can build vast lava plateaus covering thousands of square kilometers. These volcanic regions are sometimes called flood basalts because enormous amounts of lava flood across the landscape during eruptions. One of the most famous examples of fissure volcanism occurred in Iceland during the Laki eruption of 1783. Lava erupted from a fissure more than 25 kilometers long, producing massive lava flows and releasing large amounts of volcanic gases into the atmosphere. The eruption had severe environmental impacts across Europe due to the gases and ash released. Another example of fissure volcanism can be seen in the Columbia River Basalt Group in the northwestern United States. Millions of years ago, enormous fissure eruptions covered large areas of Washington, Oregon, and Idaho with thick layers of basaltic lava. These lava flows created one of the largest volcanic regions on Earth. Fissure volcanoes demonstrate that volcanic activity does not always create a single mountain. Sometimes the result is a vast volcanic landscape formed by lava spreading outward from long cracks in the crust. Complex volcanoes. Not every volcano fits neatly into a single category. Some volcanoes change their behavior over time, producing different types of eruptions that create a mixture of volcanic structures. These are known as complex volcanoes. A complex volcano is made up of several volcanic features that form during different stages of activity. Instead of a single simple shape, these volcanoes may contain lava domes, cinder cones, multiple craters, and layers of lava flows all within the same volcanic system. Over long periods of time, shifting magma pathways and repeated eruptions reshape the volcano again and again. As a result, complex volcanoes often have irregular shapes rather than the symmetrical cones seen in many stratovolcanoes. Multiple vents may open in different locations on the volcano, each producing its own eruptions and deposits. Mount Etna in Italy is one of the best-known examples of a complex volcano. It has numerous eruption vents scattered across its slopes, and many smaller cones have formed along its flanks over time. Etna has produced both explosive eruptions and long lava flows throughout its history, creating a highly diverse volcanic landscape. Because complex volcanoes evolve through many phases of activity, their structures can become very complicated. Some parts of the volcano may collapse while others continue growing through new eruptions. Lava domes may form inside craters while new vents open along the sides of the mountain. This constant reshaping shows how dynamic volcanic systems can be. Complex volcanoes remind us that volcanoes are not static landforms but evolving geological systems that continue changing over thousands of years. Submarine volcanoes. Not all volcanoes form on land. In fact, most volcanic activity on Earth actually happens beneath the oceans. Submarine volcanoes are volcanoes that erupt on the seafloor, often thousands of meters below the ocean's surface. Because these eruptions occur underwater, they usually look very different from the explosive volcanic events we see on land. When lava erupts beneath the ocean, the surrounding water cools it extremely quickly. Instead of flowing freely across the landscape, the lava often solidifies almost instantly as it comes into contact with the cold seawater. This process creates rounded structures known as pillow lava, which look like stacks of smooth, bulb-shaped rocks. These formations are very common on the ocean floor and are one of the key signs scientists use to identify underwater volcanic activity. Submarine volcanoes are especially common along mid-ocean ridges, where tectonic plates slowly move apart and magma rises to fill the gap between them. As lava erupts along these ridges, it continuously creates new oceanic crust. Over time, repeated eruptions can build large volcanic mountains beneath the sea. In some cases, these underwater volcanoes grow tall enough to eventually break through the ocean's surface and form new islands. Many island chains around the world began this way. The Hawaiian Islands, for example, started as submarine volcanoes that gradually grew higher through repeated eruptions until their summits rose above sea level. Submarine volcanoes are difficult to observe directly because of their deep ocean locations, but modern technology such as underwater robots and sonar mapping has helped scientists study them more closely. These volcanoes play an important role in shaping the seafloor and constantly renewing parts of the Earth's crust beneath the oceans. Volcanic plateaus. In some cases, volcanic eruptions do not create a single mountain at all. Instead, they produce vast areas of hardened lava that stretch across entire regions. These formations are known as volcanic plateaus. Volcanic plateaus form when extremely large volumes of fluid lava erupt from long fissures in the Earth's crust and spread across the surrounding landscape. Instead of piling up into a cone-shaped mountain, the lava flows outward in wide sheets that gradually stack on top of each other. Over time, these layers can become thousands of meters thick and cover enormous areas of land. Because the lava spreads so widely before cooling, the resulting landscape is relatively flat or gently rolling rather than mountainous. Some volcanic plateaus are among the largest volcanic features on Earth. One famous example is the Deccan Plateau in India, which formed about 66 million years ago during a period of massive volcanic eruptions. These eruptions produced enormous amounts of basaltic lava that flooded across large parts of the region. Today, the plateau covers hundreds of thousands of square kilometers and consists of many layers of solidified lava. Another example can be found in the Columbia River Plateau in the northwestern United States, where ancient fissure eruptions created thick lava flows that now form a vast volcanic landscape. Volcanic plateaus demonstrate that volcanic activity can shape the Earth on an enormous scale. Instead of creating a single volcano, these eruptions transform entire regions into layers of volcanic rock. Supervolcano systems. At the largest scale of volcanic activity are systems often referred to as supervolcanoes. Unlike typical volcanoes, a supervolcano is not defined by a single mountain or cone. Instead, it refers to a massive volcanic system capable of producing extremely large eruptions that release enormous amounts of magma and ash. These eruptions can create calderas that stretch tens of kilometers across, forming huge volcanic basins rather than tall peaks. Supervolcano eruptions are extremely rare, but when they occur, they can be among the most powerful geological events on Earth. During one of these eruptions, vast quantities of ash and volcanic gas may be thrown high into the atmosphere and spread across entire continents. The Yellowstone volcanic system in the United States is one of the most well-known examples of a supervolcano. Beneath Yellowstone lies a large magma reservoir that has produced several massive eruptions in the distant past. The caldera visible in Yellowstone today is the result of one of these enormous eruptions that occurred hundreds of thousands of years ago. Another example is the Toba caldera in Indonesia, which formed after a massive eruption around 74,000 years ago. Supervolcano systems show how powerful volcanic processes can be when huge amounts of magma accumulate beneath the Earth's crust. Although these eruptions happen very rarely, they represent the upper limits of volcanic energy on our planet. Volcanoes may appear quiet and unchanging when viewed from a distance, but their shapes reveal the powerful forces that form them deep within the Earth. From small cinder cones built from scattered fragments of rock to enormous shield volcanoes that rise from the ocean floor, each volcanic shape reflects the behavior of magma beneath the planet's surface. Some volcanoes grow through explosive eruptions that build steep mountains layer by layer, while others form through slow-moving lava flows that spread across the landscape for kilometers. In some cases, eruptions reshape the land entirely, creating huge calderas or vast volcanic plateaus. Even beneath the oceans, submarine volcanoes continue forming new crust and building underwater mountains that may eventually become islands. By studying the shapes of volcanoes, scientists can better understand how our planet works and how the forces inside the Earth continue shaping the world around us. Volcanoes are reminders that the surface of our planet is not fixed or permanent, but constantly changing as energy from deep within the Earth rises toward the surface.